What is the Laplace of t equal to? Again, that's the integral from negative infinity to infinity well, let's put e to the minus st first. Stick with the notation. F of t dt. Again, in circuits, that goes from 0 to infinity. In this case, will be f of t is t, e to the minus st dt. So this one you might have to go integration by parts. In case you forgot, you let u equals t, dv equals e to the minus st dt. That means du is equal to dt, and v is equal, you integrate that one, 1 over negative s e to the minus st. So what is the Laplace equal to? U times v minus the integral of v times du. U times v, this is u, that's v. So it's negative t over s e to the minus st minus the integral from 0 to infinity v, which is negative 1 over s e to the minus st v du. And what's du equal to? Dt. So what do we have? Negative t over s e to the minus st plus, this is a plus, now give me a minus, that ends up being really another minus sign. Minus a minus is a plus, but there's also another minus coming from that minus sign. So that final answer is going to be a minus. You're going to have 3 minus signs. Minus 1 over s squared e to the minus st. So if you factor e to the minus st out, you're going to have negative t over s minus 1 over s squared. And t is going from 0 to infinity. Now let's see, when t is infinity, this is e to the negative infinity, which is a 0, and 0 times anything is 0. Minus, when t is 0, e to the 0, that's a 1. T is 0. This is 0 minus 1 over s squared. Do the math. What do we have? 1 over s squared. So the Laplace of t is equal 1 over s squared. And you can actually try the Laplace of sine, cosine, tangent, all these functions that we use. We usually have a table that has all these values in them, the Laplace of them. The one thing I want to add to that list before I show you the table, if you have an impulse, and an impulse is actually a function that looks like this. It has a spike in it in 0 time. We call that function, I don't know, it's not delta, whatever Greek letter there. So the Laplace of that function is always equal to 1. So if you have an impulse like a lightning, hit that, a spike of voltage in a short time, the Laplace of that is 1. The other one, the Laplace of u sub t. U sub t is unit step function. Instead of a switch in circuits, we use u sub t. And if you recall what u sub t is, it has a value of 0 all the way till it hits this, then it goes to some number, which is normally a 1 here. That's a DC value. The Laplace of that, that's u sub t. So this is the impulse function. This is u sub t. The Laplace of that is equal to what? 1 over s. The Laplace, again, I'm doing t times u sub t. What I'm doing here, I'm taking the Laplace of t, but from 0 to infinity. Again, this function looks like this. Has a value of 0 all the way till you go to the lab, then it goes like this. Like we just did that one. So that's 1 over s squared. The Laplace of e to the minus alpha t u sub t. Again, this function looks like this. Has a value of 0 till you get to there, then e to the minus alpha t. So it's really decreasing. Then it goes like this. The Laplace of e to the minus alpha t, it's 1 over s plus alpha. And these, I'm just going to write them down. The Laplace of t e to the minus alpha t times u sub t. Again, all these are from 0 on. So I'm tired of writing u sub t there. So the Laplace of t, it's 1 over s plus alpha squared. The Laplace of sine wt, u sub t. The Laplace of sine, it's w over s squared plus w squared. The Laplace of cosine wt, it's s over s squared plus w squared. If you have a shift with that, the Laplace of sine wt plus theta u sub t. So this has a theta in it. So this will be, the bottom is s squared plus w squared, but for the top is going to be s times the sine of theta. Sine of theta, s times the sine of theta, plus w cosine of theta. And if this was actually a cosine, it's s times the sine of theta will be a minus w cosine theta over s squared plus w squared. I'm just going to add 2 more and then I'm going to call it quit on this video. You can go ahead and derive all of these using calculus, but we see this a lot, e to the minus alpha t sine wt. All of these u sub t, I'm just getting tired of writing u sub t. That's w over, so s plus alpha, that's a shifting here, plus w squared, and the Laplace of e to the minus alpha t cosine wt, it's equal s plus alpha over s plus alpha squared. So for these two, All you're doing, you're taking the sine and the cosine, and every time you see s, replace it with s plus alpha because of that shifting. Again, I just don't want to go through that and derive them all, but you can go ahead, knock yourself out, do some integration, and find the answer to these.